On a rooftop in Texas, there is a device that makes no sound. It has no spinning blades. From the street, you would not even notice it. And yet, the company that built it says this silent box on the edge of a roof can generate up to 50% more electricity than the solar panels sitting right next to it, in the same space, at the same cost, and through the hours when those solar panels are completely dead. It works at night. It works in winter. It works when the sky is gray and every solar panel on that roof has gone quiet. It is called Turbine, and almost no one has heard of it. The rooftops you drive past every single day, the warehouses, the factories, the big box stores are covered in empty space that could be producing power around the clock. The technology already exists. It is being installed right now. So why is it missing from every solar quote in America? By the end of this video, you are going to understand exactly how a wind generator with no visible blades actually works. You will see why it beats solar in the precise moment solar fails you: the evening, the winter, the storm. You will learn what it costs and why the math over 25 years is not close, and you will understand the real reason your solar installer has never once mentioned it to you. Because this is not a story about a gadget, this is a story about why the best technology does not always win and what it costs you when it loses. First, you need to see what your solar panels are actually doing, and more importantly, what they are not doing. Solar has one fatal limitation that no marketing brochure will put in bold print. It only works when the sun is shining on it. That sounds obvious, but follow it all the way to the end. A solar panel produces nothing at night. That is half of every 24-hour day gone. In the winter, when daylight is short and the sun sits low, output can fall by 60% or more. And winter is exactly when your heating load is highest. A passing cloud cuts production in seconds. Snow covers the panels completely. And here is the cruelest part. The hours when you need electricity the most, the early evening, when everyone comes home, turns on the lights, cooks dinner, charges the car, are the hours when the sun is already going down and your panels are fading to zero. Grid operators even have a name for this. They call it the duck curve, a daily collapse in solar output that arrives at the worst possible moment. On top of that, every solar panel slowly degrades, losing roughly 0.5% of its output every single year. And to capture meaningful power, panels need to blanket your entire roof, every usable square foot, tilted to the sun. Solar is not bad technology. It is incomplete technology. It harvests one resource from one direction for 1/2 of the day. And for 30 years, we have been told that is simply the price of clean energy. Now here is how Turbine solves the exact problem solar cannot. And the design is genuinely clever because it does not look like a wind turbine at all. Forget the giant 3-bladed machines you picture on a hillside. An Turbine unit looks like a tall, sculpted box standing on the edge of a flat roof. On its sides are 2 curved airfoils shaped like the wing of a race car turned on its end. When wind hits the edge of a building, something important happens. The building forces that air upward and accelerates it. Turbine sits exactly in that accelerated stream. The airfoils catch the wind and funnel it, amplifying the airflow and channeling it down through a small turbine hidden inside the unit where it is never exposed to the outside. Nothing spins out in the open. There are no external blades slicing the air. And that single design choice erases almost every complaint people have ever had about wind power. It is quiet. It does not throw the strobing shadow flicker that large turbines create. It does not kill birds because there is no exposed rotor for them to fly into. It works in wind coming from any direction, and because it rides the building's own edge, a single rooftop can hold a whole row of them while using only a small fraction of the surface, leaving the rest of the roof free. Where solar lies flat and passive, soaking up whatever happens to fall on it, this device stands up and actively pulls energy out of the moving air. So why does the company say it beats solar? Because of when it works, wind does not stop at sunset. In most places, wind actually picks up in the evening and through the night, the very hour solar abandons you. Wind blows in winter, often harder than in summer, the season solar is weakest. Wind blows during storms and heavy cloud, when a solar panel is producing almost nothing. Aeromine is harvesting a completely different resource on a completely different schedule. Put the two together on the same roof, and you stop depending on a single source of power. The solar panels carry the bright middle of the day, the wind units carry the mornings, the evenings, the nights, the gray days, and the cold months. Aeromine's own claim is that for a given rooftop, their system can deliver up to 50% more energy than solar panels alone would in the same footprint, at a comparable cost while taking up only around 10% of the roof. Whether that exact number holds at your site or not, the principle underneath it is rock solid. Two sources that produce at different times will always beat one source that goes dark for half the day. And this is not a concept video or a crowdfunding render. Aeromine is a real company based in Houston, Texas. The chemical giant BASF ran one of the first pilot installations on the roof of a manufacturing site. The design has been recognized as a breakthrough in clean energy, and the company is targeting exactly the buildings that make the most sense: flat commercial and industrial rooftops. And think about how much of that there is. Across the United States, there are billions of square feet of flat warehouse and factory roofs. Vast, empty, windswept surfaces that solar barely touches because the structure or the economics do not always fit. That is the opening. And Aeromine is not alone in proving the category. Other engineers have built small rooftop and ducted wind machines chasing the same idea, pulling power from the air that moves over a building. Motionless rooftop wind is no longer a fringe experiment. It is an emerging branch of clean energy that quietly does the one thing solar has never been able to do: make power after dark. Which brings us to the real question: if this technology works, if it has been installed on real buildings, if it generates power exactly when solar fails, why is it not on every rooftop in the country? Why has your solar installer never mentioned it? The answer is not some grand conspiracy. It is something more stubborn than that. It is structure. For more than 20 years, the entire solar industry has been built around one product: the flat photovoltaic panels. Every installer is trained on panels. Every financing company knows how to write a loan for panels. Every government rebate, every tax credit, every utility interconnection form is written with panels in mind. There is a deep, well-worn track running from the factory to your roof, and it carries solar panels and nothing else. Rooftop wind has almost none of that. No nationwide installer network, no standard rebate checkbox, no financing template a bank already understands, not because the technology is worse, but because the road has not been built for it yet. And there is one more thing working against it: reputation. For decades, small wind turbines genuinely were a bad idea on a roof. The old spinning blade designs were noisy, they vibrated the structure, they killed birds, and they broke down. People tried them, hated them, and concluded that rooftop wind simply does not work. The motionless design fixes those exact problems, but the bad memory lingers, so the better idea sits there, proven and quiet, waiting for the system to catch up to it. Now let me be honest, this technology is not for every roof. It works best on large flat buildings with strong wind exposure, not necessarily a typical suburban home. It needs real wind to deliver strong results, and it is still far smaller in scale than the solar industry. Most importantly, it is not a replacement for solar, it is a partner to it. That partnership is where things get interesting. Solar panels excel during sunny daytime hours but produce little at night and less during winter. Add rooftop wind units, and suddenly that same roof can generate power in the evenings, overnight, during storms, and throughout colder months. Instead of leaving roof edges unused, they become productive energy assets. Imagine two identical roofs, one with solar alone and one with solar plus rooftop wind. Over 25 years, the second roof captures energy during hours and seasons the first simply misses. That difference can add up to far more than most people expect. So what do you think? If you could add a silent rooftop wind system that works when solar does not, would you install it or stick with solar alone? Let me know in the comments.